and you wrote through and did the following. You circled your angle, you drew opposite, makes this an adjacent, and that's a hypotenuse. What trig function do you have to use to find x in this case? Which one has adjacent and hypotenuse? The second one, the cosine. So then you would write out the cosine of your angle is your adjacent over your hypotenuse. And that's all I asked you guys to do. Okay? That's it. We didn't talk about pressing buttons. I didn't care about pressing buttons yet. I'll worry about that here in a little bit. What I want to do, though, real fast, is make sure you guys chose the correct trig functions over the weekend. Okay? Yes, ma'am. I'm trying. I know. It's
Okay, let's have a sheet too.
sorry. I thought I had enough this time. I missed. Yeah, it's like I had mentioned. You don't want to get this cough. It's other than this dumb cough, I feel great. But the cough has turned itself into a headache because of the amount of times you cough, and then it's turned into that's where you're going too. And which turned into an earache. What a nightmare.
Keep walking.
It's just awful.
Keep walking. I said so. Does it matter?
No.
Yeah, that's what's off.
All right. So let's take a second. You're welcome. Let's take a second and make sure everybody got the right trig functions. 14, you used what? What was it? Sine, good. 14, you used sine. The sine of 24 is 20 over x. You okay with that? 14. 15, again, you would use sine. Sine of 50 is 18 over x. 16, what'd you use? Tangent. Tangent of 54 is x over 17. Okay. 17 was sine again, good. Sine of 68 was 18 over x. 18, what do you use? Cosine. Cosine of 75 is 11 over x. 19, you used sine, good. Sine of 73 is x over 20. 56, you used sine again, 56, or sine 56, 16 over x. 21 is another sine. This didn't really randomize it very well, did it?
Not really.
22, what'd you use?
Cosine.
Cosine, very good. 23,
Tangent.
and then 24, sine. Okay. So, obviously, picking them out isn't so bad. So, as of right now, excuse me. As of right now, we have one example where you have, I don't know if you, actually, let me ask you this question. Did you guys notice that there's only two ways that these problems were showing up? They were only showing up with a variable in the denominator or a variable in the numerator. That was the only two possible ways of doing it. So let's look at how you solve with that, because it's kind of generic no matter what. And I'm going to use number 23 as one of the examples. So on number 23, oops, wrong button. On 23, you guys told me that you used tangent, correct? You have an opposite and an adjacent. So you guys, you told me a second ago, you guys used tangent, which meant you wrote out the tangent of 36 is something over 10. Are we okay with that? Now, what I want you to think about, the tangent of some angle is just another way of writing out a fraction. It's another way of writing out a decimal. That's all that is. So it's really just some garbage looking number with a crappy decimal on the left hand side. The calculator has a button for you to use. On the right-hand side, you have x divided by 10. So what I want you to think of is, if I don't pay any attention to this tangent 36, how do you undo dividing by 10? You multiply by 10. So with that being said, if I multiply both sides by 10, I would get the following. 10 times the tangent of 36 is my value of x. Now, there's a reason why I want you guys to always put the number you're multiplying by in front of a trig value. Let me show you what happens. When you have your calculator and you press any trig function, what does it automatically open? Parentheses. Which means if you don't close the parentheses when you're done, you'll screw something up. So to alleviate that issue, I always say to put the number in front. So here's what happens. First of all, I need to make sure that you guys understand the different modes in your calculator. Luke, can I sit there for a second, please? Thanks. Now, if you guys look at your calculators, right underneath here where it says Texas Instruments, underneath the NTS in Instruments, you'll see it's 3 letters. It says DEG. Those stand for degrees, okay? That's what we call the mode that the calculator is placed in. There's a couple of different modes. If you hit the button that says, I don't know, mode, you'll see where it says DEG, RAD, and GRAD. Well, degree mode is what you're going to want to make sure everything is in geometry, okay? It is very, 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 very rare that you'll ever use anything besides that. I honestly don't think you ever will, for me, personally. I don't think any of you guys have the graphing calculator, so. But next year, when you guys go to Algebra 2, those graphing calculators all default to what's called radian mode, that RAD. It's something completely different. It deals with what's called the unit circle. It'll mess up all your values because it's not going to do what you want it to do this way. If you're using your phones or you're using your Chromebooks, I believe that you might be able to change the mode in it just to double check it. We had students who were using their cell phones earlier to try to figure that out. If you type in, see how you said you're in radian right here? Do you know how to change that? I don't either.
Yeah.
Is there a mode on there somewhere? I'm sure if you putz around with it, you might be all right.
Yeah.
Also, have you guys ever used Desmos on your Chromebook?
Yeah.
Desmos does the exact same thing as your calculator will. But there's so if you don't have your calculator on you, but you got your Chromebook, or you can't figure out how to change the mode on that, just load up Desmos on your Chromebook. But I think there's a very easy way to change the mode on there. I think it actually says mode. You just change it to degree mode, and then it works. So radians are completely different than degree measures. They're in terms of pi. We'll explain that later on, but it deals with 3.14159, that whole thing. So here's what happens. There's 2 ways of doing this. If I dummy this to being some trig theta, can I say that this value, trig theta, can stand for sine, cosine, or tangent? It's just one of the trig buttons. Because no matter which one you have, if it's 10 sine 36, 10 cosine 36, you're still doing the exact same thing. It's just some trig button. It doesn't matter what. You can have it set up this way, where your variable is in the numerator and you have a number in the denominator. This is case 1. There's only 2 cases. If this is the case where your variable winds up being in the numerator, no matter what trig function you use, it'll always work out to be this: some number times your trig value of that angle. And that'll give you your answer. Okay? So if you type this in your calculator, I want you to type it literally exactly like this: 10 tangent 36, hit enter. Also, you'll notice that your calculator will open the parenthesis. You don't need to close the parenthesis in this case because you're just multiplying. It's not a bad habit to get into to close the parenthesis, because in about a couple weeks, you'll have to be very cautious when you are dividing, because that will come up from time to time later on. So if you do this, you get, let's see, 10 tangent 36, and I'm getting this number. Everybody get that?
Yeah.
Did you get that? Did you figure it out? All right, so you're still graded, that's fine. So here's my general rule, and I think I've mentioned this before. We're always going to round to the nearest 100. I always want to go to the nearest 100. The nearest 100 is always 2 decimal places. If I'm going to round to the second decimal place, what number do I always look at? The third number. So I look at the third number here. I look at the third number. Is that a 5 or greater?
Yeah.
It's a 5, which means what do I change that 26 to? 27. So my answer here would be theta, or not theta, sorry, in this case was x. X would equal 7.27. And that's my answer. That's it. The calculator is doing the work, right? The calculator does the work for you. But I really, really, really need you guys to write down what you're typing in the calculator before you press the buttons. One of 2 reasons why. First reason, if you can't figure out how to get your calculator out of radian mode into degree mode, you can still do all of your work and not press the button at the end. You can get to the right answer and just type it in later, okay? Secondly, if I'm typing 10, my answer has to be 10 tangent 36, I write down what I'm going to type in my calculator, but let's say you accidentally do 10 cosine 36 because you weren't paying attention, and you get that. If I don't know what you wrote down, I won't know what you did to screw up, if that makes any sense. So by telling me that you wrote down this, but you came up with 8.09, I can figure it out. I can press a couple buttons in my calculator and backtrack what you screwed up. Did you hit sine by mistake? Did you hit cosine by mistake? Did you accidentally type 33 instead of 36? I'm really good at figuring that out, but I need to know what you typed to start with. Yes, sir?
Well, I was gonna say, like, if we have a sheet like the homework from we had to solve for x,
Yeah.
we just go through and write out like the 10 equals x, and that's, we go through all the problems like that.
We're gonna do in about 2 minutes. Okay. Is that a fair thing to do, Kevin?
Yeah,
Okay. Just wondering. You're about to hit your head on the tray there.
I think I did.
I think you did too. Like the drool, you got a little going on there. So remember, for all of these things, when we get to the trig stuff, I've actually been known to not let you use a calculator and just have you write out what your answer would be in literal form, okay? Because that shows me that you know how to set it up. Because really, if you can do the setup portion, press a button. I mean, you could have a Band-Aid on your thumb and you hit the wrong button because of that.
Oh no.
It happens, you know?
Oh, I can't breathe.
Now, the other one that happens, oh, I know, forgot. That was cool. You were doing like loopy-loops and stuff. I don't know how you did it.
Loopy-loops.
Good job.
You spin around and stuff. Isn't that the gymnastic term, loop-de-loop?
No.
No? I thought it was a loop-de-loop. I used to be able to do a
Lauren.
cartwheel. Why aren't you impressed?
Huh?
I can do a cartwheel.
Do it. Do it. Please.
What a sissy!
What does being having to do a cartwheel have anything to do with that? That's not even, no.
Wait,
No,
not anything like peeing.
no, I know, but no, we don't call people sissies. That's no. That's not good. My luck, I would have just ran and done it, and I would have kicked my feet right into the projector.
Wait, no, just like put your hands up like this and walk under it, see if you will, and then we'll.
Yes, I can do that.
Let's just see. Flat. flat hands because you're doing a cartwheel. You're not.
You realize that my toes would be pointed at that case like this and hit that.
Well, that's not good gymnastic form.
Anyway, so if I go back, we'll print it in a second. Now, the other style that happens looks like this.
I saw it this morning.
The other spot that can happen on 22, we all said that this was a cosine of v, correct?
Yeah.
So we wrote it out, you guys had this written out, it was the cosine of 39 was 19 over x. And you had that written down on your papers, correct?
Yeah.
All right. Now, bless you. This is the other case of where the variable could be. Right now, we're not worrying about how to find angles. We'll get to that next week sometime, or maybe towards the end of this week, I'm not sure. But for right now, your variable can either be in the numerator or in the denominator. So what I want you to think about is this. Is this a true or a false statement? It's a true statement. Okay. Now, when you have two fractions that are equal to each other, we call those proportions. All right. Well, trig ratios and their sides opposites, they're equal ratios, they're equal fractions, so they are proportional. Here's what happens if you remember. If I exchange these two on the along the diagonal, you would get 2/6, which is 1/3. Is that a true or false statement? That's also true. So basically what happens is that if you've got two fractions that are equal to each other, you can exchange them on the diagonal and still get a true statement. The reason why I want excuse me. The reason why I wanted to show you that was because does this change the problem at all? If I put that over 1, it doesn't change it at all, which means that I can flip these on the diagonal, and it's still a true statement. So if I ever have a variable in the denominator, all I have to do is this. Exchange-o, change-o. Every time. Every time. If you have, this is your second case. There's only 2 ways to solve here. If you have some trig value of some angle, is something divided by your unknown. Whenever the variable is in the denominator of that fraction, all you have to do is exchange-o, change-o on the diagonal. And that is something I learned in college, exchange-o, change-o. That's what they called it. Sounds good.
Did they really?
Yes. I went to Northern. What's that? I went to Cary Grove.
Gross. I hate to show up myself.
I went to Cary Grove. Cary Grove is, it's town of Cary and Fox River Grove is the next sort of town. It's between Crystal Lake and Barrington. Cary County. So what happens then, there's basically only 2 ways to solve these problems. You're either going to multiply by a denominator or you're going to divide by a trig function. That's it. That's all you do. Okay? So take a couple minutes, and as of right now, you guys have all 12 of those on the back side written out in terms of the ratios. What I want you to do is set it up so that way number times some trig value equals x. Press the buttons. X is some number divided by trig function. Write it out, press the buttons. So if I'm doing number, let's see, we did 13. If we do number 14, I think we did that one. If I go to 15, on number 15, right now, you guys have the following written down. You have sine of 50 is 18 over x. You have that written down. Is that case 1 or case 2? Case 2. So I write down x is 18 over the sine of 50. And then I press my buttons. I want you to take 5, 10 minutes, whatever it takes to do this. Do this next step, and then round to the nearest hundredth. Yes, ma'am.
Did you guys solve for number 20?
Did you get the weird roots?
No, I got it from the book and stuff.
Oh, I haven't done, for which number though?
Tell me your son did.
Oh, I don't know, I don't have my calculator on me. I will agree with you, yes.
Can you come here?
Real fast though, before I go over here real quick, I want you guys to pay attention real quick to number, what is it? Number 18. I want to show you guys real quick something about number 18. Now, when you guys do this one, this was a cosine problem, correct? On 18? Yes. So you had cosine of 75 is 11 over x. Case 1, case 2. Case 2. So exchange-o, change-o. Now, your calculator is going to spit this out. It's 11 over 6, 11 over 2, I think. I think that's what it does, doesn't it? Is that what it did?
Yes.
Okay. There's a reason why it does that. Do you know how to get rid of that? Do the double arrow, yeah. When we're solving these things with trig values, if it ever gives you anything in simplified radical form, just hit the double arrow. But there's a reason why it does this. Cosine of 75. Well, that's the cosine. Why is this not working? That's the cosine of 30, well, let me write it this way, 45 plus 30. Okay? When you guys get into maybe a little in algebra 2, but more than likely if you get to pre-calc, this is actually what they call a half angle problem. The reason that this works is because you can rewrite 75 in terms of 2 of the special right triangles. Remember our special right angles that we had were 30s, 60s, and 45s? 75 is a combination of a 45 and a 30. What happens is there's actually this long-winded formula that says, well, that's the cosine of 45 times the cosine of 30 minus the sine of 45. Why is this not working at all today? That's the sine of 30. Well, what happens is that you get this huge long-winded half-angle, double-angle formula to make that work, and that's why the calculator spits out in terms of radicals, because the cosine of 45 is root 2 over 2. The cosine of 30 is 1/2, so you get root 2 over 4. Excuse me. Sine of 45 is root 2 over 2. I'm sorry, it's not 1/2. This is root 3 over 2. So this is root 6 over 4. You guys are really, really happy about learning this, I can tell.
Are you just like showing us what's in there?
Yeah.
Just, like,
And then, you're not going to worry about this in geometry, but the reason why the calculators spit out radicals for you sometimes is because you can combine a 30 and a 45 to create a 75. It'll happen the same way if you have like 115, or like a 135, I know 90, 45, things like that. So, but whatever you see, what's this? Oh, you did? All right, cool. So now you're all right. All right, so take a couple minutes, like I said. We'll check them in a couple minutes, all right? Listen.
Oh, wait. What were we doing on number 15? Right. Do you put the 50 in front, or can you, is like that the yeah. Do you have to put 3 numbers after or 2?
What's that?
Do you have to put like 3 numbers?
Always round to the nearest hundredths. You're always going to go 2 decimal places, which means you'll always look at the 3rd digit to see if it's a 5 or bigger. Okay. What do you want to check? Let's roll through a couple of these real quick. I don't have my calculator on me, so. Hey, let's look at 17. Oh, maybe it's 18. So 17, if you did this one, you used cosine, right? I'm sorry, sine. So the sine of 68 is 18 over x. Case 1, case 2. Case 2. Case 2, so that means it's just x. He's just doing this today.
Do that sound like tech?
Yeah, I know. And then if you press buttons in the calculator, 18. I noticed that a lot of you guys were using fraction bars. Good. Keep using fraction bars with these things. It'll come in handy later on when we need fraction bars. What was it? Sine of, was it 58?
68.
Thank you. 19.41?
Yep.
All right. Let's see which one that is. So many of these are sine. I didn't realize that many sine words. 16. What one do you guys use for 16? Case 1, good.
I think I used case.
So this is a case 1. Variable's up on the top, so it's case 1. So when you write it out, first step you would do is just write down 17 tangent of 54 equals x. Press the buttons, what'd you get?
23.40.
23 point what? 40? Yeah. I think that's what we had earlier. Because it was like 398 or something.
Yeah, I don't really remember.
So you just round it up that way, and you're done. Okay? All I'm concentrating on with these things with you guys as of right now is really to be able to identify what trig function you're going to use, how do you write it out, and how do you press the buttons via case 1, case 2. Tomorrow, when we get down to the auditorium, we're going to do something a little bit different. Very simple, we're still using trig.
It's like trigonometry, but playful.
Guys, we're still using trig, but like I've said, what's going to happen is that we're going to take a protractor. It's going to have a string on it and a paper clip for a weight. As you tilt this back and forth, the paper clip will always stay perpendicular to the ground. It's kind of like what they call a plumb bob. That's what they use in construction. And what you're going to do is you're going to measure an angle from your eyesight looking at an object. So somebody will be over here helping you figure that out. There's a quick little math that you will do with that. It's very easy. And we're going to draw up some diagrams to figure out distances of how tall an object is or how far away you are from an object. Basically, tomorrow you're going to use tangent like 8 or 9 times.
Oh,
right?
no.
Okay? Because it's the easiest way to set some of these things through.
Oh.
What I have here, though, is basically the exact same thing what we've been doing. It's just some more problems to practice. Obviously, we probably won't have time to go over all these tomorrow because we'll be in the auditorium. But here's what I want you to do on these and have them all done by Wednesday. So if I'm looking at number 2, here is what I want you guys to do on these things. Just like we have been. First thing you're going to do is circle your angle and label your parts. Second thing you're going to do then, you just throw it right there in the middle there, and that's fine. The second thing you're going to do then is figure out what trig function are you going to have. Well, which trig function is opposite and adjacent? Tangent, good. And I would write it out. The tangent of 21 is 15 over x. What's the next thing I'm going to do?
Multiply.
It's case 2, very good. It's case 2, cross multiply, like you were saying. I would write down x will equal 15 over the tangent of 21. And then I press my buttons. So I want you guys to do those steps. in doing those steps and that little bit of extra work up front, believe me, it's going to make everything else easier. I want all of it. Okay? It won't take long. Yes, sir.
Wait, for number.
Yeah, please. But you don't know how to do any of this stuff. Go, Monte. Yeah, Dad, start watching the videos. Yes, please. Was there spares I can add just since the head of this stuff it was easier that way. You guys need one? Yeah. I'm sorry. Alright, so where are you going to go tomorrow? Yeah, just go right there. Make sure that you guys don't have any food there. They will yell at you for that because they don't like that.
Does Ronnie go to the schools? Like seniors?
There actually is a practical use for math. Believe it or not, from time to time we like to show you guys some cool stuff. Yes, ma'am. Yeah, make sure you bring your stuff like you would normally. We're just gonna be down there. That's all. Because we'll still, I don't know if you'll still have to write down a few things. It's not gonna be like full-on notes or anything like that, but you're still gonna have to do some calculations and write down a few things. Yeah.